So in this video, I'm going to be teaching you about trig reciprocal identities. So first we're going to go over the basic trig identities, functions. So sine theta equals opposite of our hypotenuse, and in a circle it equals the y value over the radius. For cosine theta, it is adjacent over hypotenuse, and on a circle it is the x value over the radius. And for tangent theta, it is opposite over adjacent, and on a circle it is the y value over the x value. So these are the three basic trig functions, and cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent. So for cosecant, it is hypotenuse over opposite, and on a circle it equals the radius over the y value. For secant theta, it is hypotenuse over adjacent, and on a circle it is the radius over the x value. For cotangent, it is adjacent over opposite, on a circle it is the x value over the y value. So what are the basic trig reciprocal identities? So they are formulas to solve for cosecant, secant, and cotangent. So first you need to know what a reciprocal is. So let's say you have a number, and that number is like n. So what is the reciprocal of n? So to solve for the reciprocal of n, you have to take n and put it 1 over n. That is the reciprocal of n. So let's say you have the number 2. So the reciprocal of 2 would be 1 over 2. Do you understand that? So we're going to apply the same principle for figuring out the reciprocal identities. So let's start off with sine theta. So sine theta is equal to opposite over hypotenuse. So if we want to find the reciprocal of sine theta, so how would we do this? We would use the reciprocal formula of 1 over n. Since our n, the value we want to make the reciprocal as, is sine, so what we would do is put 1 over sine theta. And to solve for this, we would plug in this and put it here. So technically it would be 1 over opposite divided by hypotenuse. And then 1 divided by opposite over hypotenuse equals 1 times hypotenuse over hypotenuse over opposite, and that would equal hypotenuse over opposite, and hypotenuse over opposite is actually equal to cosecant theta. So thus 1 over sine theta equals cosecant theta. So that is the reciprocal identity for the trig function sine theta. And if you did this for cosine and tangent, you'd get the three basic reciprocal identities, which are 1 over sine theta equals cosecant theta. 1 over cosine theta equals secant theta. And then 1 over tangent theta equals cotangent theta. Now, you can switch these two and then you would get 1 over cosecant theta equals sine theta, and the same thing here and here. So you would have 1 over secant theta equals cosine theta, and then 1 over cotangent theta equals tangent theta. So these are the basic six reciprocal identities. So then, if we know that sine theta equals 1 over cosecant theta, then if we do sine theta times cosecant theta, it would equal 1. So to prove that, we would substitute sine theta and put this in. So 1 over cosecant theta times cosecant theta, and that is over 1, would equal 1, since these would cancel out and become 1. So 1 times 1 equals 1. So then, if you apply the same principle to all the other trig functions, you would find out that sine theta times cosecant theta equals 1, and cosine theta times secant theta equals 1, and then you would find out that tangent theta times cotangent theta equals 1. So these are the basic reciprocal identities. So I hope you learned about trig reciprocal identities, and please like and share this video and leave a comment and subscribe. Thank you. Bye.